Hello everyone, this is Mr. Mohammed Hussein from Al Noor International School, written Algebra teacher. The lesson of week 11 will be chapter 13, lesson 2. It's about angles and the unit circle. The objectives of this lesson are as follows: to work with angles in standard position, to find coordinates of point in the unit circle, to identify coterminal angles, to find the sine and the cosine of an angle using unit circle. Now let's see the standard position of an angle. What is the standard position of an angle? An angle is made up of two rays, as you know, called the initial and terminal sides. An angle which are measured in trigonometry usually start from what is called standard position. The angle theta, which is measured from positive x-axis, is in the standard position in the two figures shown below. From the first figure, the angle theta is measured from positive x-axis counterclockwise direction, and second figure shows the angle theta is measured in clockwise direction still, which is in standard position. So make sure that your initial side always lies on the positive x-axis. Let's see some facts about a 30, 60, 90 and a 45, 45, 90 triangle. In a 30, 60, 90 triangle, from geometry, the sides of a triangle have the following ratio. Side opposite the 30 angle is x side, opposite the 60 angle is x root 3, and side opposite the 90-degree angle or hypotenuse is 2x. As you can see from the first figure, the triangle is a 30, 60, 90 triangle. Assuming the shorter side is x, the height will be x root 3 and the hypotenuse will be 2x. In a 45, 45, 90 triangle from geometry, the sides of triangle have the following ratio. Side opposite the 45 angle is x side, opposite the 90 angle or hypotenuse is x root 2. In this figure, the triangle is isosceles right triangle, which means the two legs have the same measurements. The hypotenuse will be x root 2. By the way, these relations can be verified by using Pythagorean theorem, which means from the first figure, x squared plus x root 3 squared will give you 2 times x squared, and from the second figure, x squared plus x squared is equal to x root 2 squared. In this slide, we are going to define the unit circle. The unit circle is centered around the origin and has a radius of 1 unit. How can you find the cosine and the sine of an angle using a unit circle? A unit circle can be used to help find the cosine and the sine values for that angle. The cosine of an angle theta is always equal to x coordinates of a point where the terminal side intersects the unit circle, and the sine theta is equal to the y coordinates of point where the terminal side intersects the unit circle. Now let's see the relationship between the xy coordinates and the cosine and sine of an angle. The sine theta is opposite over hypotenuse, which is y over 1 from this figure, which is equals to y, and the cosine theta is equal to adjacent over hypotenuse, which is x over 1 or equal to x. Let's see once again some facts of standard position of an angle. When an angle is in a standard position, the initial side is on the positive axis, which means it does not move. the terminal side opens up, the vertex of an angle is located at the origin. So measuring an angle inside the position, if the terminal side rotates counterclockwise, then the angle is positive. If the terminal side rotates clockwise, then the angle is negative. The full rotation is always 360. However, the rotation can go on forever in either direction. The next slide will show you shortly the relationship between terminal side, vertex, initial side of a given angle A. As you can see from the figure, the terminal side, which is opens up, and the vertex is at origin. The initial side lies on the positive x-axis. So an angle A is in standard position. In this figure, you can simply understand which direction is clockwise and which direction is counterclockwise. If you have confusion, watch out this figure and you can understand the two directions. Now let's see the relationship between angles and quadrants. If the angle goes counterclockwise, then the terminal side passes through the quadrant in the following order: quadrant 1, 2, 3, and then 4. If the angle goes clockwise, then the terminal side passes through the reverse order: 4, 3, 2, 1. In this slide, we are going to define the coterminal angles. Coterminal angles are angles that have the same terminal sides but different measurements. There is an infinite number of coterminal angles for a given angle, both positive and negative. To find the measure of a coterminal angle, either add or subtract 360 to or from the angle measurement. If less than 360, you can also use the opposite sine angle needed to complete the rotation. For your further knowledge, to find the coterminal of angle, you can use the formula 360 plus or minus n times theta, where n is positive natural number and theta is an angle. I'll repeat once again. To find a coterminal angle of any given angle, you can use the formula 360 plus or minus n times theta, where n stands for the natural number runs from 1 to 3 and extra, and theta is an angle. As you can see from this figure, coterminal angles are two different angles, rotations with the same terminal side. For example, 32 and 392 and 572 are coterminal angles because the terminal side of these three angles are the same. As you can see from the figure, 32 is in quadrant 1 and 392 will be counterclockwise, and it lies on the same terminal side that 32 lies. The same thing is true for 572. In this slide, we are going to see how to find the sine and the cosine of an angle using this unit circle, which contains the special angles. To find the coordinates of intersecting point, draw the angle, determine whether a rotating exists. Reference angles used in this determination. Use the ratio of either triangle in computing the length of the unknown side. Will be vertical and horizontal legs. Hypotenuse is always 1 as it's unit circle, so the vertical length is y and the horizontal length is x value. So from this figure at the right, how can I find sine of 60? Just go directly to 60 degree watch out its coordinates. It's 1 over 2 and root 3 over 2. So the first coordinates represent the x value or cosine theta, that's 1 over 2. Root 3 over 2 stands for the y value, or it is sine theta, which is sine 60. So sine 60 is root 3 over 2. So try the rest using these facts.